Let's do a question based on Newton's second law in this video. A child pulls an 11 kilogram wagon with a horizontal handle whose mass is 1.8 kilogram, accelerating the wagon and handle at 2.5 meter per second scale. Find the tension forces at each end of the handle, and also why these tension forces are different. So this is of course talking about tension, acceleration. So the tension on the handle and the whole system is accelerating. So this is dealing with forces and acceleration. So the Newton's second law is the major concept that we're going to use in here. And also you can see there are multiple objects involved in this problem. So these handle as well as the wagon. So there's some multiple objects. So that can also be included in the multiple objects. Okay, so in developing a strategy, the first thing we should do is identify the equation that could be useful. So the equation net force, then the Newton's second law, that's F net equals MA is the equation that's useful. And the next thing we should do is draw a diagram of the situation. So we have a wagon. So that's a wagon. And then the handle, because I need to find the tension force on each end of the handle, I'm just because I need to find the tension forces on each end of the handle, I'm just making it a little bit longer. So this is the handle, and then this is each end of this, and this is the wagon. So the mass of each object, so it's a M wagon and this is M handle. And after we draw the diagram, so the next thing is identify the forces acting on each object. So the handle, the child is pulling it with a force. Because it's a string, the force can be written as the tension force, which I'm going to write as T1. So T1 is the force with which the child is pulling. So what's the other force acting on the handle? Because this wagon is resisting its motion, the wagon is pulling it towards it. So that's T2. So T1 and T2 are the forces acting on the wagon, on the handle, and on the wagon there is a force which is the handle is exerting, so which I'm saying, okay, this is the force. T3 is acting on the wagon which the handle is exerting on it. So these are the different forces involved, and there's no other forces in the wagon in the horizontal direction. Also, even though there's a vertical forces which we neglect in this case because we're analyzing the motion on the horizontal direction. And I'm going to take the horizontal direction, this direction, as positive. So the next thing in developing is to apply this Newton's second law for the two objects and also the Newton's third law if it's applicable. So first of all, look at this handle, the net force for the handle. The net force is T1 minus T2. So that's the net force on the handle, and that equals the mass of the handle is mh, and it's accelerating with the a. So the one thing we should be remembering is if the whole system, if two objects are connected and if they're accelerating, the whole system will be having a same acceleration. So that's this acceleration. And for the wagon, so the net force is just the T3, so T3 is the only force acting on it, and that equals M wagon A. And on this one, so T2 is the force wagon is exerting on the handle, and T3 is the force handle is exerting on the wagon. So these two forces are actually action-reaction pair. So these two forces are action-reaction pair. So all I can say as T2 is equal to T3, so in magnitude. Let's now evaluate this problem. So the first thing which is easy for me now is to find T2, because T2 equals T3 and that equals mass of wagon times A. So mass of wagon is 11 kilogram and the whole system is accelerating at 2.5 meter per second square. So the answer I get is 27.5 kilogram meter per second square is Newton. So 27.5 Newton. And now let's find T1. That's the force, this force, the force acting, the child is pulling on the wagon. So that's, the child is pulling on the handle. So T1 equals T2, so I'm just rearranging this equation, T2 plus mh, the whole handle, times A, and that equals, T2 is 27.5 Newton plus mass of the handle is 1.8 kilogram times 2.5 meter per second square, and the answer is 32 Newton. Okay, so now we got T1 and T2, the force acting on the handle on the opposite, on the two ends of the handle. T1 is 32 Newton and T2 is 27.5 Newton. So the next question it's asked is why they are different. Imagine what will happen if they are the same. So if T1 and T2 are 32 Newton, what will happen? So the net force on the handle is actually going to be 0, and if the net force is 0, the system can't accelerate. So that won't be true. So that's one of the reasons why these forces are not equal. Okay, so now let's assess the answer to see if their answer is making any sense. So first thing, from this one it seems that 32 Newton is the force the child is applying for the handle and the wagon together. The child has to accelerate handle and the wagon. And T3 is the force handle is exerting on the wagon, which is 27.5 Newton. So which is less. So that makes sense because wagon needs, this T3 has to accelerate only wagon, but the T1 has to accelerate both wagon and handle. And also we have included units everywhere. So we can say, okay, I have done a proper unit check, and then we have ended up with the correct units for the final answer. So the unit check is done, and T1 is greater than T3, which makes sense. So these are the kind of things you can say in the assess stage.